Before calculus, there is one idea underneath everything in machine learning: the function. A model, in the end, is just one very big function. So let's understand exactly what a function is, starting from the simplest possible picture. Think of a function as a machine. You feed it an input, it does something, it gives back an output. Here is a simple one: f of x equals 2x plus 1. Put in 3 and it doubles it to 6, then adds 1, out comes 7. Put in 0, out comes 1. Same input, always the same output. That reliability is what makes it a function. To see a function, we use the coordinate plane. Draw two number lines crossing at 0, the horizontal x-axis and the vertical y-axis. Every point is a pair: how far across and how far up. The point 3, 2 means 3 to the right and 2 up. This simple grid is the stage where all of our math will play out. Now we can draw the function. For each input x, we plot the point x, f of x. At x equals 1, f is 3, plot 1, 3. At x equals 2, f is 5, plot 2, 5. Connect all such points, and our function 2x plus 1 traces a perfectly straight line. The graph is the function made visible. Straight-line functions are called linear, and they have a tidy form: y equals mx plus b. The b is where the line crosses the vertical axis, the starting height. The m is the slope, how steeply it rises. A slope of 2 means every step right, 2 steps up. Slope will become one of the most important ideas in this entire course. But the world is rarely a straight line. Take f of x equals x squared. Now the output grows faster and faster, and the graph curves into a parabola. There are many such shapes, curves that bend, rise, and flatten. Machine learning needs these curved, nonlinear functions because real patterns are rarely straight. One more step. A function can take more than one input. F of x and y might combine two numbers into one. With two inputs and one output, its graph is no longer a line, but a surface, like a landscape of hills and valleys. Real models take hundreds of inputs at once. We cannot draw those, but the idea is exactly the same. And that is the punchline. A machine learning model is just a function. Its inputs are the features of your data, the pixels, the numbers. Its output is a prediction. Training the model means searching for the one function out of billions that fits your data best. Everything ahead is about understanding and shaping that function. So, functions. A machine that turns inputs into outputs, drawn as a graph on the plane. Straight lines or bending curves or high-dimensional surfaces. And a model is simply the biggest function of all. Now we need a way to describe its inputs, the data itself. Next, vectors.